problem like this in quite a little while. Two lines are perpendicular. That means we know that their slopes are negative reciprocals of one another. They give us the one line. They tell us it has an equation of 2y equals px plus 7. Oh, that's a bummer because it's not in slope-intercept form. Let's go ahead and get that in slope-intercept form before we do anything else. So that means we're going to divide everything by 2 here, which means we've got y is equal to p over 2x plus 7 over 2. So the slope of this line is equal to p over 2. Notice that. Okay, the other equation is already in slope-intercept form. The slope of that line is q over 4. All right, so in order to find an actual set of values for p and q, these two slopes need to be negative reciprocals of each other. So what I'm going to do is I'm just going to start out with writing p over 2, and then I'm going to make this be a negative reciprocal of that, which means I'd have negative 4 over q. Do you follow what I did? Negative reciprocal, okay? So the idea is, essentially what we need to do is figure out what value in here could go in here and what value could go in here. That would make this a true statement or an equality like it says. All right, so I'm going to say that I want q to be 8. Could I choose q to be 10? Sure I could, but I'm just arbitrarily choosing q to be 8. Look, it says find a possible set of values. There are an infinite number of correct answers, okay? So I'm going to say that I want q to be 8. So if q is equal to 8, notice that to get me over here to 8, that's 2 times 4 is 8, right? Okay? Or I could say 8 divided by 4 is 2, okay? So negative 4 divided by 4 is equal to, wait for it, that means it is negative 1, okay? All right? Now let's just cross multiply to make sure this is right. Negative 1 times 8 is negative 8. 2 times negative 4 is negative 8. Yep, we've got it working. So P could equal negative 1. Q could equal 8. What if you would have chosen a different value? As long as your equality is true, you're totally fine.